Hi everyone, my name is Kate and today we are going to be looking at vectors for IGCSE Mathematics. Let's jump into it. Alright, so before we can get into questions, we need to talk about the fundamentals of vectors and what a vector actually is. So, a vector is basically a quantity that has two things: magnitude and direction. So what do I mean by that? Magnitude is basically a quantity or a value. So for example, 20 kilometers or 60 kgs. It's an amount. Whereas direction is basically obviously going north or south or left or right or up or down. We're going in a specific direction. So a vector contains two things: an amount and a direction. So it's like a set of instructions. A vector is basically telling you how to get somewhere. In the example that I've given here, we have O, which I call home or the origin. Okay, now let's say we want to go from home to the shops. Now the home to the shops can be represented by the magnitude of A. Now that letter represents a number. That could be 10 kilometers, 50 meters. It depends on how far you live from the shops. But it is in the direction of A. Home to shops is in the positive direction. Okay, now let's say home to school is represented by the letter B. Now this is a different magnitude in a different direction. Now, one of the fundamentals about vectors is that a lot of the time when you are calculating vectors, you might not know how to get from A to B. So we can't go directly from A to B because we don't know how to get there. So for example, in real life, if I was saying, hey, I'm at the shops and now I want to go to school and I'm late for school, so I got to get there. Do you think you're going to risk, if you don't have a GPS and you are late, going straight from the shops to the school? Probably not. So instead, what you might do is go from shops to home, which you do know, and then home to school. It might take you a little bit longer, but at least you're going to get there. So what the fundamentals of vectors is that you never go directly from one letter to another. You always go the long way round because you know how to get there. Imagine a world without GPSs. That is basically vectors. You are going the way that you know, not the most direct route. Fundamental things to understand about vectors is that they contain both magnitude and direction, and that you don't often go straight from A to B. You'll go the long way around. All right, so now that we've explained what a vector is and some of the fundamentals about vectors, it's time we get into the questions. All right, so I have 5 questions for us today, which we will work through, and hopefully some of the knowledge I give you, you'll be able to apply to questions you get in your own exam. All right, so let's have a look at question 1. Question 1 basically says, OABC is a parallelogram. OA is equal to P and OC is equal to Q. E is a point on AB such that AE is in a ratio to EB of 3:1. Find OE in terms of P and Q in its simplest form. Now, if I read that out loud and overwhelmed you, I don't blame you. So the most important thing with vectors is, before you even try to attempt to answer the question, as I always say, it is to break the question down into simpler wording, simpler understanding. So let's investigate. Again, I love the word investigate before we answer. Okay, so OABC is a parallelogram, as we can see this. So what do we know about parallelograms? Well, we know that opposite sides are parallel. That basically means that if OA is P, that means that BC is also P, because they are parallel. And the same can be said that OC is Q, so that means AB must also be Q. Now note that I have put in arrows, okay? I've not just labeled them as P and Q. Now the reason I put arrows, well, that's because I said vectors also need direction. All right, so the direction has to be the same as the parallel side. We can't suddenly switch the arrow. So P is an upward vector and Q is a vector that goes to the right. Okay, cool. So now that we've established that, let's look at the second part, which we've already established technically because we've already figured out that OA is P and OC is Q, and we've put those values in. So now let's look at the third row. E is a point on AB such that AE is in a ratio of EB of 3:1. Now that is where most people go, I'm going to skip this question. Don't know what's going on. Help me. Okay, so that's what I'm going to do. I'm going to help you. Okay, so basically what that means is that the length of AB can be split into 3 and 1. Okay, so I can't just write 3 and 1 because that doesn't make any sense. Because a ratio is a part of a whole, okay? Because it is a part of the whole line of AB. So in order to figure out the values of those specific ratios, what we do is we add the two ratios together. So we add 3 and 1 and we get 4. So that basically means A to E is 3/4 of the line and E to B is 1/4 of the line. I hope that makes sense. If, for example, we had a ratio of 5:4, I would add those and that would equal 9. So the length of my line would then be 5/9 and 4/9. Okay, so that's quite important to understand because you're going to use that value in your calculation. So now I have established the diagram, I've simplified the diagram, and I know all the values of all the lines on the diagram. So now I can answer the question. So the question wants us to find OE in terms of P and Q. So what that basically means is we need to give the examiner the directions, the instructions on how to get from O to E. So we travel along the lines. Now we can't go straight from O to E. Why can't we go straight from O to E? Well, we don't know the directions. It's like I said earlier, if you don't know how to get from the shops to school, then all you simply do is you go from the shops to home, then home to school, because you know how to do that. So it's the same fundamental principle. Instead of going straight from O to E, we're going to go the long way around because we actually know how to get there. So we're going to go from O to A. Okay, I'm just going to use a different color so that you can see the different lines. So from O to A, which we know the value of, and from A to E. I am choosing a color and being indecisive. A to E, okay? So we're going from O to A, and then we're going from A to E. I've picked a color you cannot see. That is wonderful, Kate. Well done. But basically, what I'm trying to say is if I go from O to A and then A to E, that will give me O to E, which is what I'm looking for. Okay, so what is O to A? Well, we know O to A is positive P. Now, what do I mean when I say positive P? Well, that's because we're going the same direction as the arrow. We're not going backwards, we're going forwards. Remember I said that P is an upward vector. And because we are traveling upward, it's positive. All right, now we're going from A to E, which we've established is 3/4 of AB. Now, what is AB? Well, because we know it's a parallelogram, we figured out that AB is Q, just like OC. So that means it's 3/4 of Q. Okay, I'm going to pick a slightly different color because it's easier to see. So we are again going in the same direction as the arrow. So it's positive 3/4Q. And that is your answer. Okay, P plus 3/4Q is how you get from O to E. So maybe it's not the direct route, but it is a set of instructions that'll get you from O to E. All right, let's move on to the next question. Question 2. This one is a little bit more complicated because we don't have all of the set values, but that's okay. Let us read the question and then investigate the diagram. Okay, let me go back to my blue. O is the origin. Nice and simple. And OPQR is a parallelogram. SOP is a straight line with SO equaling OP. TRQ is a straight line with TR equaling RQ, STV is a straight line, and ST and TV is in a ratio of 2 to 1, and OR is A, and OP is B. Okay, I'm not going to read the question we have to answer now, because I first want to investigate the diagram before I get overwhelmed by the diagram. Okay, so we know that O is the origin. Now, it's extremely important that you understand that the origin is what I call home. It's your base. And the next question that we're going to do, which I have had an eye on, it's very important to know that that's the origin for that question. Okay, so SOP is a straight line with SO equaling OP. So SO equaling OP. Now that basically means that if OP is equal to B and SO is the same as OP, that means that SO must also equal B. Again, I'm putting on the information on the diagram. In your exam, you're welcome to do this. Maybe do it in pencil so it doesn't overwhelm the examiner or the diagram, but just put in the information. Don't try and hold everything in your head. All right. TRQ is a straight line with TR equaling RQ. So we've got TR equaling RQ. Now this is a parallelogram. Now, as we said in the previous question, the opposite sides are parallel. So that basically means that these two are also B. Okay? Now, if you look closely at the diagram, you've probably already figured out that these two are also A because of the fact that it is a parallelogram and these lines are parallel. Again, take note of the direction of the arrow. Okay, cool. Now we can't read the question yet because now we have to investigate this 2 to 1 ratio. So STV is a straight line where ST is in a ratio of 2 to 1. So that basically means that this is 2, this is 1. Okay, so this would be 2 out of 3 and 1 out of 3 of the entire line of SV. Remember, what we do is we add the ratios and then we pop the correct number over the total to get the part of the line that we're looking for. All right, now we can get to the question. Find in terms of A and B, in its simplest form, the position vector of T. What is a position vector? Let's ask ourselves that question first. A position vector, and this is very important to understand, is a vector from the origin. Okay, so let's just quickly make sure that you understand that. A position vector is a vector from the origin. A vector from the origin, or O. Okay, so if you are ever asked to give a position vector, you are trying to find O to the letter you're given, which in this case is T. So we're trying to give instructions from how to get from O to T. Now, we can't go straight from O to T because we don't know how to get there. So instead, what we're going to do is we're going to go a different route. Now, what's nice about this is there are 2 different ways we can go. We can either go from O to R and then R to T, or from O to S and then S to T. It doesn't matter. I'm going to do the first one that we suggested, so O to R and then R to T. Now, I'm going to write down what I'm going to do. Again, it's very important in Cambridge that you write down what it is you are going to do. So O to T is O to R and then R to T, as we established. O to R and then R to T. Okay, so what is O to R? Now, we established that O to R is equal to A, and we are going in the right direction. So we can say positive A. Now, you don't have to write the positive. I'm just writing the positive so that you can understand the difference between positive and negative. Okay, now we've got our first encounter of us going against the line. R to T means we're going backwards. Now, what do you think that means? It means that yes, the magnitude is B, but this time the direction is negative because we're going the opposite direction. All right, and that is our vector, A minus B. All right, you don't have to, again, put the positive by the A. So now we're going to try and figure out R to V, okay? So r to v is a very interesting thing because we actually do not have a value for the line t to v. So we know r, again, because we know that vectors you can't go directly, we have to go a different way. So r to v will then equal r to t, then t to v. So r to t, then t to v. Okay, all right, so r to t we already know is minus b. We're going the opposite direction. Okay, but t to v is a little bit more tricky because we don't know what t to v is. We have to figure that out, and we have to figure that out based on our two ratios here. Okay, so the idea behind this is that when you are given, okay, let me try and explain this with my hands. I find it easier to explain with my hands. So when you are given a line and you know the full length of the line, right? You know that the full length of the line is A, for example. Let me draw a diagram. Full length of the line is A. Okay, then you are told that I've got a point here on the line, like in the previous question, and I know that 1 is 2/5 and 1 is 3/5. Okay, that's quite easy because we know that the full length of the line is A. So if we're going from this point to this point, it would just be 2/5 of A. Okay, but what happens if the ratio is given and we only know a part of the line? Like in our example here. So we know that S to T is equal to A. But we also know that S to V is in a ratio of 2 to 1. So we know that S to T is 2/3 and T to V is 1/3. Okay. So we're going to approach this kind of question a little bit differently because it's not saying it's 1/3 of A. Right? Because A does not extend all the way to V. Instead, what we're going to do is we're going to realize that S to V is split into 3 parts, okay? So we've got part 1, part 2. I'm just going to do the parts in a different color. So part 1 is from S to the middle of ST. Part 2 is from the middle of ST to T, and part 3 is the middle of T to V. So basically, we know the line is split up into 3 parts, where A represents 2 of the parts. Now, if A represents 2 of the parts, then what do you think one part would be? Well, it would be a half of A. So we now know that one part is a half of A, because if we add those 2 parts together, we get A. I hope I'm making sense, but basically what you do is you try to split your line into parts, and then you figure out what one part is, and then we can just multiply that by the ratio. So because we know that each part is a half A now, and we know that T to V is one part, we just say 1 times a half A, which is just a half A. So now we know that T to V is a half of A. All right, I hope that made sense. This is where vectors can get a little bit complicated, and please let me know down below in the comments if that didn't make sense and I can explain it in a better way. But that is fundamentally giving us the idea of a half A. So that gives us our answer. So we know that R to V now is minus B plus a half A. All right, then it says, show that PT is parallel to RV. Okay, so PT is parallel to RV. I've written so much on my diagram now. This is why it's best to do it in pencil, because if it does get overwhelming, you can rub it out. But we need to show that P to T is parallel to R to V. Okay, so in order to do that, we need to understand what a parallel line is. Now, a parallel line means it goes in the same direction. And now, remember, direction is very important in vectors. So, in order for a line to be parallel, it can have different magnitudes but be in the same direction. Now, we look at parallel lines in terms of ratios when it comes to vectors. So we need to compare the line of P to T to the line of r to v. So we already know the line of r to v is minus b plus a half a. Cool, great. Now we need to find the line of p to t. So let's do that. P to t is going, either we can go p to q and then q to t, or we can go p to s and then s to t. All right, doesn't matter which way. I'm going to go the first way again. So I'm just going to write it out. P to t is equal to p to s and then s to t. Okay, so p to s we know is a, which we established because it's parallel to OR, which is also a. So that is a. And then s to t is minus, because again we're going the opposite direction, 2b. Okay, because we're going through two b's. So minus 2b. And now if these plus minuses, it will just become, can cancel out, and we just have a minus 2b. We now need to compare these two lines. So I'm just going to rearrange this formula so that the b's are in the same place and the a's are in the same place. But the idea here is that I don't know if you can spot it, but remember I said to you that it's all about ratios. So they're in the same direction because the b is negative and the a is positive. Check one. But they have to be in the same ratio in order to be parallel. Okay, so basically, my ratio of b to a in PT is equal to 2 to 1. Don't worry about the negatives now, we're just looking at the ratios. And in r to v, it's equal to 1 to a half. Now, if you do the calculations correctly, you can see that we can multiply both sides of this ratio by 2 and get 2 to 1. Which means these two lines are in the same ratio, therefore they are parallel. So same ratio equals parallel. Okay, provided that the negatives and positives line up. I want us to investigate this diagram without reading the question. So already we know that there is a parallelogram. I read that just to confirm that, okay? But because it's a parallelogram, based on our previous questions, I'm pretty sure you've already jumped to the idea that CB is P and OC is Q. I hope you were able to do that. If not, please go and watch go back and watch the first question, because that explains that in more detail. All right. So we've now established that CB is B and AB is Q. And again, I'm using my arrows. All right, now we can see that M is the midpoint of OB. Midpoint meaning these are each a half, okay? Because a midpoint is in a ratio of 1 to 1. It doesn't say that, it doesn't need to say that, because midpoint is just half-half, okay? And then we are told that N is a point on AB such that AN is to NB 3 to do. 3 to 2. What does 3 to do mean? I have no idea. All right, so again, we add these, so we get 5. That means the longer line is going to be 3 over 5, and the shorter line will be 2 over 5. Okay, and we know that AB is Q, so that means that A to N is 3/5 of Q, and N to B is 2/5 of Q. Let's figure out the questions. So it says find in terms of P and Q, giving yourself some a set of directions, O to B. All right, so O to B, here we go. We can't go straight from O to B because we have no idea what it is except for that M is in the middle of them. But we don't actually have any parallel lines we can compare, so we're going to have to go the long way. So we can go two directions, O to A to B, or O to C, C to B. Now my eyes went immediately from O to C and C to B, so that's what I'm going to do. But if your eyes went in the other direction, that doesn't matter, provided that you know all of the directions, which we do. Okay, so O to B, again, I'm going to write out my instructions before I just randomly start putting P's and Q's. O to C and C to B. So what is O to C? Well, we can see that O to C is Q, and we're going in the positive direction. And C to B is P, and again, we're going in the positive direction. So that basically means OB is Q plus P. Nice and easy. All right. If you don't find it easy, please don't worry. That's just one of the easier questions that you can get. All right, now we need to find C to M. Now this one's a little bit more complicated because again, we don't entirely know what M is, but we do now. Because remember we said that M is a half of OB. Now previously we didn't know what OB is, but now we just figured it out. So that basically means that M is a half of OB, which is Q to P. I just want you to be able to understand that. Okay, so again, we can't go straight from C to M, so we're going to have to go the long way around. So we're going to go from C to O and then O to M. Again, you can also go C to B and then B to M. The only reason that I am choosing C to O and then O to M is because my positive direction is OB, which is this way. And I'd much rather have a positive direction with a more complicated line. All right, but again, just make sure that you consider your directions. So C to M is equal to O, C to O, and then O, sorry, I forgot to write C to M. C to M is equal to C to O, and then O to M. Now, C to O is basically opposite Q, so negative Q, all right? And then O to M is a half of O to B. And we've already established that O to B is Q plus P. So it would be a half of Q plus P. So basically what we're going to do now is we are going to simplify. This is the first time we actually have to simplify because we have more than, we have two Q's. So I'm going to expand my brackets and I'm basically going to say minus Q plus a half Q plus a half P. Now minus Q plus a half Q is minus a half Q. So that basically gives me minus a half Q plus a half P. Okay, so the last question is M to N. All right, so M to N is this line over here. All right, again, I'm probably going to use a different color for this question just so that we don't get overwhelmed. M to N. Now again, we cannot go straight from M to N, so we need to go the long way around. And again, there are two different ways, but I'm going to go the short way because if I go from M to O, O to A to N, I'm going the really long way around. So I'm going to go from M to B and then from B to N, okay? Because that's only two vectors I'll need to cross. So let's write that down. M to N is equal to M to B and then B to N. All right, so M to B. Well, we know it's a half of O to B, and we know that O to B is Q plus P. So it is a half of Q plus P. Now, what is B to N? Well, we already established this 2/5, 3/5 thing of AB. So B to N we know is 2/5 of Q, which is the full line. But check the direction. The direction is up and we're going down. So it would be negative 2/5 of Q. Just want to double check that it is Q. Yes, it is. All right, so now we need to simplify. So I'm going to expand my brackets and say a half Q plus a half P minus 2/5 of Q. Now, if you're not sure what 1/2 minus 2/5 is, which I also don't know off the top of my head, so I'm just going to pop that quickly into my calculator and basically, whoa, I can't use a calculator. Yes, I can. Is 1/10. So that basically means we have a half of P plus 1/10 of Q. And that is M to N. All right. And yeah, we have two more questions to cover before we finish the video. I know this is quite a long video, but hopefully doing 5 examples with you will help you to be able to approach these questions yourself. All right, let's get into question 4. All right, so with question 4, we are looking at a triangle. This time it is not a parallelogram, so slightly different, but we still approach it in the same way. So let's first investigate before we attempt any of the questions. So we've got OT is T, OU is U, checking and making note of the direction of OT and OU. And we know that UY is equal to 2 of YT. Now, this is a ratio, but it's not given in the same way that our other questions have given the ratios. So we basically are going to make our own ratio. So if there's no number, it's 1. And then obviously it's 2. So it's 1 to 2. If we add them, we get 3. So basically U to Y is 2/3 and Y to T is 1/3. All right, we've now figured out our diagram. Let's get into the question. So we have to find O to Y. All right, now this kind of question is a little bit challenging because we haven't done any of the pre-work that we need to do. So we're going to have to do that in this question. What do I mean by that? Well, let's have a look on how we get from O to Y. We can't go directly, so we're going to go the long way around. So we go from O to U, and then we go from U to Y. Okay, so that would be great in theory. Okay, but O to U we know is U. But what on earth is U to Y? Well, we know that U to Y is 2/3. Great, but of what? Well, it's 2/3 of U to T. But we don't have U to T. So we are going to have to find U to T. So U to T is going to be a whole separate thing we're going to find. So U to T is going from U to O and then O to T. U to O and then O to T. Okay, so now what we're going to do is figure that out. So U to O is going backwards, so it's negative U, and O to T is going forward, so it's positive T. So we have T minus U, okay? Or minus U plus T, it doesn't matter. Okay, so that basically means we now know that U to T is T minus U. So that means we now have a value for it. So we have 2/3 of T minus U. Now we expand. So we've got U plus 2/3T minus 2/3U. U minus 2/3 gives us 1 minus 2/3, which is 1/3. So our answer is basically 2/3T minus 1/3U. All right. Now we've got another parallel question. So it says, Z is on OT and YZ is parallel to UO. Okay, Z is on OT. So let's figure out where that is. So Z is somewhere on OT where YZ is parallel to UO. So basically, it has to be a parallel line somewhere like this, okay? So Z is somewhere there. Basically, we know that Y to Z is parallel to U to O, which basically means they are in they have this the same ratio. Remember we spoke about parallel lines and ratios, okay? So basically, if YZ, right, is parallel to UO, that basically means that they are equidistant apart, okay, because they're in the same ratio, okay, because they have an equal distance wherever you go. And so based on that idea, if U to Y is 2/3, then O to Z must also be 2/3. So it would be 2/3 of T. I don't know if that makes sense, but because of the fact that they're parallel, they're equidistant, so it doesn't matter where this line is, it will be the same ratio, the same scalar value. Okay, cool. 2/3 T is your answer of O to Z. So that's a little bit of a higher level question. And if you struggle with those kinds of questions, don't worry. I think what it's really important to do is not get overwhelmed by the higher end questions and focus on being able to get your fundamental understanding. All right, let's approach question 5. So basically, let's read the question and investigate the diagram. So in the diagram, O to A is A and O to B is B, as shown on the diagram. And now we know that A to K and k to b is 2 to 1. So we have, again, we add them together. So a to k is 2/3 and b to k is 1/3. Find a to c in terms of a and b. So we are trying to get from a to c. Okay, now again, we can't go directly from A to C because we don't know how to get there. What we can do, however, is go from A to K and then K to C. Okay, now this is a little bit more tricky, and as you can see, this is a 4-mark question, so we're going to have to do a little bit of pre-working. So let's just write down what we're doing. We've got A to K, and then K to C. You could also go A to O and O to C. That's also an option. But basically, I'm going to go the slightly shorter way and try and show you how to do that. So, A to K. Now, we know that it's 2/3, but it's 2/3 of what? Well, it's 2/3 of A to B. So, we now need to find A to B. So A to B is going to equal A to O, O to B. A to O, then O to B. Now, A to O is going in the opposite direction of the arrow, so it's minus A, and then O to B is going in the same direction as the arrow, so it's plus B. And if you want to not have this negative and positive, we can swap them around, but you don't have to. That's a personal preference. All right, so we now know that A to B is B minus A, so A to K is 2/3 of B minus A. Great, we've got the first part. Now we need to figure out what K to C is. Now, in order to figure out what K to C is, we need to have noticed these 2 lines. Now, if you don't know what that means, it means those lines are equal. They have the same value. So we're not actually going to figure out K to C. We're going to figure out O to K, and because they're the same length, they're the same value. So let's figure out what O to K is. I'm going to do it up here so you can see. So O to K is going from O to B and B to K, or O to A and A to K. Now, we already know what A to K is. So I'm going to go this way around. So O to A plus A to K. So O to A is equal to A, and then A to K is equal to 2/3 of, what did we say? B minus A. So if I simplify that, I've got A plus 2/3 B minus 2/3 A. 1 minus 2/3 is positive 1/3. So I have 2/3 B plus 1/3 A. Okay, cool. So now that is what O to K is, which is the same as K to C. So I can add that here, 2/3 B plus 1/3 A. All right, and now I can expand this guy, and I've got 2/3 B minus 2/3 A plus 2/3 B plus 1/3 A. And if I simplify that, I end up with 4/3 B minus 2/3 plus 1/3 is going to give me minus 1/3 A. And there is your final answer. All right, I hope that makes sense. That is the final question that we're going to be doing today. So, if you followed along with me, I hope that you understood and I gave you some knowledge that you didn't have before. Please let me know down in the comments if you have any questions or any video requests. And yeah, good luck with your exams whenever you write them, and I will see you in the next video. Bye for now.